Okay. All right. So hello everyone. Welcome to another day where we are continuing our game engine, 3D game engine in Golang. And I think we reached a very nice point now where we are actually going to talk about entities and components. Perhaps we'll wrap up a basic implementation today. And this should be a very big, potentially advancement in the usability of the engine, or at least giving structure. You don't have to use this, probably, but it will help. So maybe, yeah, we're live. Let's give an explanation. Let's discuss what this means for people who don't know. We'll give an intro about entities and components. So we're not doing ECS. Let me zoom in for you guys. So we won't be doing ECS, but we're doing components, kind of game objects components, similar to Unity and Unreal both. So let's, I think, discuss both right here. And if someone has questions on this, please, send a message on Twitch, or if you're watching on YouTube, you can just leave a comment and, we can discuss all of this. So let's think about a game, right? Let's say we have a player. It's kind of a big player. Finding the right size hard. So we have a player object. Maybe we have, let's say, an enemy, perhaps, and maybe a boss. Choose one type of enemy, right? And these guys are game objects. There are some entities. So I use these kind of interchangeably. When I say game object or entity, it's the same thing. It's something that exists in the game and has some properties, right? So the player is one entity, the enemy is one entity, and so on for the boss. Right there. Now, how is behavior defined? The way we did, for example, on Flappy Bird, when we were kind of testing nMage, we just made our own structs, and that's one way. I think even what's his name, Raylib, does the same thing. It just gives you the basic functionality, but object handling you do yourself. You just create your own structs. You define it in any way you like. You want to adopt this, you want to do ECS, up to you. Now, and that's what we did in Flappy. There is no predefined structure. We did whatever we want, and this could be completely okay. But if you want to make it a bit easier for people, and maybe like pick an approach to be used in the editor and in the engine as a whole, you want to go with something else. So one way that people have come up with, which is very popular, as I said, Unity and Unreal, they both do this by default, is you say each entity, and let's say this is the name at the top, is simply a list of components, nothing really more. Functionality and the data are combined together. So maybe here. So data, and I'm going to kind of talk about what this means, but we can say data and functionality come together. Functionality. Both of these things are called the components. So components equal data plus functionality. And this is the core idea. ECS does a different thing, entity component systems. I won't talk about those here. They're very famous nowadays. A lot of people are talking about them. You can watch videos that talk about them, but for now, we're just going to talk about entity component, not entity component system, just entities, components, or like game objects and components. So a component is something that has data and functionality built into it. So it has a bunch of functions and data. For example, one component can be, which we did in Flappy Bird, if you watch the older videos, is the transform component. What's our transform? Well, it was basically nothing more than position, rotation, scale. Right? And it gave us a bunch of functions to give us access and like to edit those in a controlled way, because we also cached out of those a model matrix, right? So it contained the data and it contained functions to operate on the data. This transform can be called a component. So enemy and player and boss, everything in this case would have transform, right? So here you can imagine our player has a transform component, and this is essentially what we'll implement today, is this system for entities and transforms. So this is one component. Maybe I will make a dotted line to say this is component. Same thing here, transform, and same thing here, right? Just down. So one component was used, the same logic, basically the same code was used on multiple entities. So we have code sharing, we can share things around. Maybe this guy has a script kind of logic and other things. Let's say it's player movement, right? This reads inputs and moves the player around and so on with speed and a bunch of variables. These guys won't have player input, but they will have an AI component potentially, right? With different settings. This will have an AI component and this as well. And obviously each component is like a different instantiation of the struct. And so, you know, the transform here has a different value than the transform here and so on. Same thing for AI. So we can have one AI, like one big AI script, but by configuring the values, the enemy would behave differently than the boss. Right? Now, obviously, you can keep this away from nMage and let the user of the engine implement all of this, but I think it would be really nice to have nMage have this functionality. And I'm not sure, like, you know, you can always build other ways if for some reason you want to, right? So if someone has questions, you guys feel free to, you know, ask or put a comment, but this is the highest level, like, basic idea about all of this. Once we have this structure down, we can actually start talking about scenes. Then we can build around scenes, we can build levels, we can save and load and so on. So it really opens up the ability to do a lot of things in an easy way. So now that we have this, you know, again, so we'll focus today on entities and components. That's what we'll build. And then we can look at maybe make a sample component, like let's build the transform component and think about that. Okay, so we have this. Let's go into Mr. nMage and start building. So first, this will be its own package. So let's do an entity package, right? And then entity.go package entity, right? Oh, one thing, I think generics would help for this. So I'm going to update nMage to use Go 1.18 because I want access to generics. So let's just go and tidy, make sure everything is fine. Let's just run this case. Yep, so all's good. Right, so what did we want? We said we need something to define an entity, an object. The entity can represent a player, can be whatever it is. And by this definition, so far, it's not much. An entity is just like a collection of components. Maybe you have some other data, maybe you want to give it a name, like some defaults. But in general, even the name, if you really want to go far, you can make that a component, like base entity data component or something, whatever. For now, we'll start something simple. If we want to change it, we can. So we want an entity, and we want a component. I'll just say comp. I don't want long names. Maybe this is an interface. We'll see. I think so. So what's an entity? It has an ID, I think for sure. And what else? A list of components, I think. Components is just an array of components. That's about it. Now, the core idea is that you can implement your own components, right? So let's say, like we talked about, the transform component. So transform component. This guy needs to be able to go into this array. So this cannot be a direct struct. This is probably going to be an interface, right? And what do we want? Like for now, I think let's at least require components to have a name that we can query, maybe for debugging or to help us show things. And yeah, so let's say this is our component. This is one thing, and we have maybe a position, a vec3. We have rotation is actually a quaternion, and scale, right? Just like as a sample thing. Now let's say func test, just to try things out in here. So let's say we want to create a new entity. What would that involve? First, we need to e entity. We need to give an ID. So this will probably be centralized, because we want each entity to have a unique ID, maybe global to the unique ID within the scene, or maybe even for the entire game. We can think about that. That's why it's a UN64. That will be more than enough. But for now, I'll pick like 100 is our ID. Then we have components. So I'll just start it off with 0. Now I want to add, let's say, the transform component. So what are we going to do? We want to say, well, e.components will just append the transform component. And then we can set like, okay, I will start with zeros everywhere. A new quaternion, this guy. Oh, they're not pointers. Let's make pointers. And scale, new vec3. I think I like new vec3 more. Now, obviously, this is complaining because this is not a component. It requires this function to be implemented. So let's implement that. So I'll say t transform component. It wants a name function that returns a string, and we can just say return transform component. And I think we need to give it as a pointer. That's it. So now we have an entity thing where we can have an array of components, and the components can be anything that we define. So next we might have like, a player controller or something, and that guy will have its own logic. It will have maybe a player position, not position, that's in the transform, maybe speed, things like that, plus functions to operate on it. And that can also be added in here as long as things satisfy this interface. Now we just need to be careful not to make this too much, because I don't want it to be like annoying for people to create new components, right? Okay, now obviously, now that we have components, we need a way to extract components. So let's say I have an entity, I have a bunch of components on it. I want to get the transform component so that I can use it, extract data out of it, things like that. So how are we going to do that? We need a new function. So this is our entity, our component so far, it's just an interface. We need something like getComponent. And what do you take? Well, you give us an entity and you tell us what component you want, and we give you back that component. The thing is, how do you tell us what component you want? Now, the reason I switched to Go 1.18 is because I want this defined as the generic value here. Like the value you define tells us what you want. Because otherwise we would have like maybe an enum that says component type, and the enum would be, you know, per component, and you have to remember to set it. I don't think I want that. We can try if this turns out bad, but for now what I'm going to do is I'm going to make a generic function that takes a component. You can request anything. Say, give me, do you have this component? What are we going to return to you? Well, the component you asked for. And all we have to do is very simple. Loop over components, and we can get the components, and okay. What do you call it? e.components I, right? So here we have an interface. We don't know what this is. Is this like a transform component? Is a dplayer movement component? What? We don't know. But when you call this function, you're going to tell us the type that you want. So we are going to cast it, well, assert the type, not cast it, type assert to T. We're asking Go, is this interface of this type? Is it the type that we want? If it is, okay will be true. So we can say if okay, return components. You're done. That's it. Otherwise, we can return T. Well, let's give this guy a default out value, whatever the default is, right? This will hopefully be null because this is an interface. You will need to send us probably pointers. But yeah, so we just search, very simple. We say, is this component the one you want? If so, return it. Otherwise, you just get null. So let's use this and see. Here where we added the component already, then we can say, you know, get component. Which component do we want? Well, we want a transform component. And this is a pointer because otherwise it won't satisfy the interface. So we want the transform component. All right, what's your entity? This entity. And now we can check, and you know, we can print line got component transform component, right? We can even try 2 times. So before we add it, we should get null. Get component 1, try 1, and this is try 2. 1 time before we add it, 1 time after. And if we check the type here, we are getting transform component directly. So we don't need to cast. The usage code is very simple, and I like this. I want to keep the usage code very straightforward. So Go is immediately giving us, the function is giving us the type we want, or no. Right? So let's test this. I'm going to disable essentially the engine. I'll just say, you know, entity dot test, I think we call it, yeah, test, and then we can return. I don't want anything else to run for now. Maybe zoom in a bit. So yeah, so first time we got a null, and then second time we got the transform component. So that's probably position, that's the quaternion, and this is the scale. That's it. That's all there is to it. It's very simple. And this is the core idea. Now, I would like if, honestly, this wasn't there. Like, I'm thinking, because at least when 1.18 first came out, the performance can be bad. Like, how this function is generated, you can either get one function per type that you're accessing, or one function that internally checks what type you're asking it for. And if you ask for pointers, then we'll potentially get worse performance. It would be better if we say ask for the normal thing and then return out a pointer. That would be preferable, I believe. But then it won't satisfy this. Like, you can just ask for anything, which might be fine, honestly. Like, let's say we say you can give us anything. We'll try to find it for you. And we return to you a pointer to it. That's it. Now, this is an interface, so everything inside, I think, will be a pointer already. Or T T does not implement. What do you mean? We don't care about. Does not implement components. It doesn't matter. I don't think it does. It's just an interface. I don't get it. Really? Does not implement components, so we have to implement that. Is this what it is? Yeah, unfortunately, unless we take this and we give this back. Same thing. Yeah, maybe not. I was hoping to avoid, maybe we can think of something else later on. But I would like if we can just pass the type, not a pointer to it. And I guess here, if you remove this, then you can pass type directly. Yeah. Depends on how you implemented the logic. But that's okay. I think that's, for now it's okay. Let's confirm again that we get the data, and we do. Right, so we have now basic entities, components, we have get component. What do we want more? We need to add components. So in some systems, you are not allowed to add more than one type of component. So for example, you cannot add more than one AI component on the thing. We leave this up to the programmer, right? We want to be flexible. So we'll allow you to add more than one of the same component. If you don't want to add more than one, you know, up to you. So let's say we want to do add component. It will be the same thing. Maybe you don't need to make it generic in this case because we're not returning anything. I just made it generic here because I want to return the correct type immediately. You say, I want transform component pointer, we give you that, or we give you none. Otherwise, for this, no need. You just give us, here is a component. C, and we don't return any. And all we have to do is e.components equals append C. That's it. So add component, get component. Now, if you have more, there is a case where, let's say we have two transform components on the thing, on the entity. This function is going to get us only the first one. If I want to get the second one, then we need something else. I think it's enough for us to say get all components of type, right? And you tell us what you want, but what we're going to do is return you an array of. So out equals, you know, this. We loop. If we find one that you want, we'll append, right? That's it. So that's the only difference. We return. So if you have multiple transforms, we'll give you all of them, and then it's up to you to kind of deal with them. And then we want remove. So add, get, remove. I mean, we can even skip remove maybe so far. And, you know, if you have any questions, please ask. I'll ignore remove for now. I'll do it later. It's nothing. We just have to slice out the array. Add component, get all. And let's do that. Let's do another one. Let's say we add another transform components. We have 2 of them. And the second one, we will make it have a scale of 1, 1, 1. So one time we get only 1. One time get all components of type. Same signature. You just say, you call a different function, then you take this methods. So we should see 2. Yeah. So this guy, and then we got 2 pointers exactly. This one is probably this, the first component, and this is the second component. Let's do, I want to see the whole thing. Get component 3. I hope this gives us the whole thing. No. Fine. Let's do 0, 0, 1. Okay, so the first one, we have scaled all zeros, and then the second one, we have all ones. At least it's ordered, so this is the nice part. It's just an array. We guarantee the order as long as, if you insert them in this order, you get them out in the same order. So this is good. Now, what we probably want is someone needs to store entities, store generated ID so far. We need a place to have all of this. Let's see. So this is probably going to be the scene, I'm thinking. Because what's the scene? The scene is basically our level. We can even maybe call it that. And we can imagine a level is nothing more than a list of entities. That's it. Just a list of entities. And we want identifiers because if you want to talk about another entity, maybe you just store the ID. And then you can ask the system, is this entity still available? Maybe at the end of the last frame it got deleted. Right? We don't know. So guess we can see. And then we need a centralized place to create entities because, what do you call it? I'm thinking we need some kind of metadata per entity. So we can even make that a component. And the system injects that component automatically because we want to know, like, this is one way at least, is the entity active? Is it deactivated? Is it deleted or like going to be deleted at the end of the frame? Things like that. So we need a way of knowing this information. Now, potentially you don't do it on the entity level. We can have some arrays or hash maps. So if your entity gets deactivated, we put it in an array or a hash map of deactivated entities. That's, I think, completely possible. That might be a better way. Yeah. This is one way. Right, so I'll keep it right like this for now. Add entity. Or create entity. So we need like a new entity function. And I'm not sure whether this should come here or go on the level. If we put it here, it's kind of global. Might be better to have it on the level. Let's have a look. Let's start making what they call scenes. I just call them level, I think. It's a game engine. Call things levels. Level.go. Right. So what's the level? Right now, maybe it has a name. And it's just entities. A list of entity.entity. That's literally it. That's all we care about. I mean, in the future, you can have it more fancy structure, like a full scene hierarchy with like partitioning, but yeah, for now, it's okay. Okay, so you want to do func new level, right? And for now, all we want is like a name, and we give you back a level and return level name, and we are going to assert that name is not equal to empty. Otherwise, we will tell you that name level name cannot be empty, right? And we'll just initialize this to nothing. Honestly, why not give it some default? We know that we'll have entities. We just like 50. Yeah, sure. And so now that we have a level, I don't know, we can go. Okay, 2 minutes, that's good. We need a way of adding entities. Now, the level can handle creation and therefore also handle IDs. So like the same ID can be duplicated in different levels. That's one way. Or or we don't. Or we can have IDs global on the entire game. So if your ID is 10 for a given entity, that 10 is unique even if you go to a different level. Might be useful. I don't know. Might be useful. Because if we want to load multiple levels or something like that, might be a good idea actually. So maybe entity can handle all creation of entities and have kind of counter. So something like variable entity count, or like total created entities. And this is just in64 0. So every time you create a new entity, we can increment the counter and set that as the ID. So the first entity you create will be ID1 and then ID2, etc., etc. Even if you delete an entity, we'll just give you the next ID. UN64 will basically never finish. Yeah, maybe. But might complicate things a bit. Because then you need to save this basically as part of your engine data. So you'll have scene data, you'll have engine data. It's like how many, how big is this number? Per project, let's say. Per project you're making. Any ideas? I think for now, let's do the simplest thing. And then perhaps we'll think about this later on. Let's do func L level add, or we just say new entity. New entity. Then it returns an entity, something like this. It feels weird. It feels weird to have the levels taking care of this. Yeah. Maybe we can have like a registry. So something that keeps track of entities instead of making it global, because with global, we can only have like a global count, and maybe we don't want in some cases. Yeah, so maybe we'll have like an entity registry. I know. And this guy, it doesn't actually. So you create entities through the registry, and then you can put them in a level. And if you create them through the same registry, the good part is you can move entities between levels. So I can literally take the same entity with the same data and everything, and even if I'm loading a new level, I can just move it to that new level. And I know for a fact that the IDs will not collide. I won't have any issues. Perhaps, yeah. A level can just embed a registry for now as well. That's just fine. Yeah, I think I'll use this for now. It won't be anything fancy. Total, same thing. Total created entities. UN64. This will basically never finish. And func new registry, and we just give you. We do that, right? And the registry can have now can give us new entity. Pointer. I think not pointer. So what we need to do is increment this, and I'm going to assume maybe you want to use this concurrently. So in parallel, you're creating entities, multiple threads, maybe. So we can use an atomic dot add uint64. Now you just say, well, here is the thing, please add one to it. And that should do. So E is just a poor entity, and we add one, and then the ID is equal to the new value. So we start at 0, and then we add 1, becomes 1, and the first guy starts with an ID of 1, and then returning. This is good because if the level stores its own registry, we can simply save the registry as part of saving the level. And then when we load, we know how far this is. Because you can create and delete entities. And in that case, let's say we created 10 and then we deleted the 10th entity. We have no way of knowing how many we have created. So something needs to store this value. So next time we create, we know we'll not conflict with anything present or anything that has any ID that has occurred in the past. And this is very powerful, I believe. Now, these IDs can be more than this. It can be generational, perhaps. We'll do this for now, then we'll see. We might just change this way. Yeah. Because here's the thing. If we have an array, let's say of size, we make array entity of size 10,000, right? That's the max entities we'll ever create in 11, for example, right? Like now we create E1, E2, E3, and then we delete E2. Here we have nothing, and then E3. Then we want to add E4. So E1, nothing, E3, E4. We can add E4 here, but here we have an empty slot, and we don't want to slice it out of the array. That's too much copying. What would be better is for us to reuse this one. So we come back and we put some, for example, E5 can use this, or E4 itself can be put here instead of at the end. And only when it's full, we can add more and more. So in a sense, the IDs can be connected to where they are in the array, actually, instead of being a counter. If you're at index 0, your ID is 0. If you're at index 1, ID is 1, etc. But this is called something like, I think, generational indices, which just means the index, the ID of the entity is actually its index in this array, in the registry, for example. We can move this into the registry, right? We can move this. And this guy just has a registry, actually. Registry. And the problem happens when E2 here will have ID. So E2.id equals 1, right? It's an index 1. But then E4 comes along and it also has ID 1. If someone is storing an index, storing the ID, and it wants to query the level, does this guy still exist? Perhaps he has the ID of E2, but right now E4 is there. When we check, we will think, oh, it's there. Right? We'll think, oh, it's right there. That's obviously not good. So we need a way of saying an additional data to say that, well, actually, although they are in the same index, they are different things. So how do we do that? The idea is actually not that advanced, and there could be several variations of it, but this is one. So let's say our ID is uint64. So what's that? This is 8 bytes. So we have, byte 1, byte 2, and so on. Byte 3, byte 4. Let's put it here. Byte 5. Byte 6, byte 7, and finally byte 8. Instead of using this whole thing as an index into the array, I mean, the array will never be uint64 log. That's just huge. What if we reserve some of it? For example, we'll take the top byte and we say this part is the index, right, in the array. But the top byte of it's the same uint64, but we're talking on the bits, right? So the top byte of that, this guy is actually what we call a generation. Icon generation. What does that mean? Well, assume we have the same array, E1, entity 1, entity 2, and entity 3. E2 dot ID will be the generation part, will be generation 0 maybe, and the index part will be 1 because it's index 1 in the array. Now, later on, this guy gets deleted and then E4 gets inserted. And since this is a free spot, we might as well insert it here. E3, right? So E4 ID will have the same index part, but the top byte is a different generation. So generation will be 1, and this one will be 1. The index is the same, but by checking the generation as well, we can know whether this is actually the same entity or not. Right? So this is a very nice way, and the check is still the same. All you have to do is just check one integer. It's nothing. It's extremely fast. We don't even have to separate them. When we check, we just say if ID you passed us is the same as entity ID, and that's it. And they won't be the same because this top part increases. And if this happens again for this slot, it will be generation 2, etc. But for the other slots, it's the same generation. So for this slot, it's still generation 0. When it gets deleted and replaced, maybe E5 comes in here, right? Then this guy will have a generation of 1, index of 1, index of 0. So this guy is at the generation 1, while index 1 is already a generation 2. Something along those lines. Now, obviously, there is the question is like, oh, what if like the generation is 1 byte? So after 255 generations, this is going to loop back to 0. And once you do that, you might have a conflict, but hopefully this will be long enough and you won't be deleting the same entity again and again, creating it. So by the time it loops back, if it ever does, the people who had the ID to it would have updated the ID or gone by now. Now you can do more here, obviously. Like for example, maybe if it got cleared, you don't reuse it immediately. You just keep appending for other spots, and after a while, you give a chance to other things, and then you reuse. You don't always reuse. So, there's a lot here that we can do, but for today, I'm just going to go with something most basic. And I think the registry idea is nice. We can add generation indices perhaps later. For now, registry is something that holds entities, and the level is a registry plus more things. We don't need this anymore, I don't think. What we do now is so we need to assert, first of all, that the length of the entities, actually no, so we need one thing here, which is entity count, because this will be a pre-allocated array, I think. So how many entities we have? Honestly, in 32 is probably enough. We have more than 4 billion entities. Fine, we'll keep it. So we need to assert that entity count is less than the length of entities, because this is pre-allocated. Otherwise, we fail and we say this needs to be 64. Cannot add more entities to registry because it is full. All right, and then when we create new registry, maybe we say registry size. And registry size just has Structs, right? Something like this. So this is the maximum entities you can have. So now we need to go and find an empty place in the array. And we need to handle deletion as well. So how do we say, because we're not storing pointers, I don't think I want to do that. I want to have like a flat array for performance. We need a way of saying these slots are free, these slots, you know, yeah. Perhaps we can use other parts. Oops. So for example, the 1 byte can be generation, and then second byte can be flags, for example. Yeah, we can do that definitely, because we still have a ton of bytes. Even just 4 bytes for index, this is still 4 billion entities. I don't think you want 4 billion, but we'll try to keep more. So 1 byte for this. If we use this for flags, we'll have 8 flags, which I think is enough, probably. Because what do we want? For now, we just want to say, is it free or not? That's it. And we can play with this later on. But let's say, we'll have this. So entity count, entity, and I wasn't thinking of doing registry today, but we can, or at least part of it. So the ID, what's an ID? 1 byte. We say byte 1 generation. Byte 2 flags. Bytes byte 1, byte 2, and then bytes 3 to 8 is index. So we have a lot. We have a good number of bytes. I have 6 bytes for index. That's a ton. This is kind of the setup. So if we have this, then we first need to find an empty slot, and 2, we need to do generation. Yeah. So we need to loop until we find something with flag 0. And then, because the way we will delete entities is really just set a flag and this is deleted. That's it. We won't do anything more. We can even have this in a parallel array if we want. but this is more efficient for storage.
Okay.
So okay, let's do, we don't have a way of storing generation though per field. Maybe we can use a hash map for that. Okay, let's forget generation for now. We'll just do addition. So we're going to go through for everything in Mr. Registry dot entities. Appointment type. For all the entities, let's go on and find something empty, not taken. So perhaps 0 is this. So let's say you know, now that we have this, we can say byte 2 is what, 8 bits, right? And this bit is perhaps let's see. So for this bit, 0 equals 3 and 1 equals deleted, taken. Or we can reset to 0. So we can say for now, like we can use the flag idea later on, but for just this, we can reset the ID to 0. If the ID is 0, that means it's free. I think that's a good idea. We'll never use 0. That means it's initialized. So we can say if R, so E, I'll just take a pointer to it so I don't want to copy too much. R entities I, if E dot ID is 0, that means this slot is free. And then in that case, we can do EID equals just the index equals I for now. Later on, we'll have like a way to track generation, maybe set some flags. We can do this. But for now, the entire thing is just the index. So we set the index and let's have it to do implement generational in indices. So if this E equals this, and perhaps we just set E, right? Like or just here, this is added entities. We don't need this. E what do we want? Get entities. If it's free, then set the ID. I think when we delete it, we will clear the components, so that's fine. Yeah, when we reset it to 0, we just set an empty thing. And since this is the registry, we'll give you a pointer always. Since the registry owns this data, if you want to edit the entity, you work with the pointer. Yeah, that's why it was confusing. Then we can just return In here we panic. We should always be able to give you. So failed to add, to create new entity because we did not find a free spots in the registry. Why did the assert not go off? Right. We forgot one thing here is once we set it, we do what do you call it? We need to increment entity count. So this might be called parallel. No, with this registry we cannot, because 2 threads would be searching the array and finding it, so it's not thread safe. I think this is okay. So r.entity count plus. Okay, that's it. So now we have a registry. We can create new entities, and that's it. Level might even maybe embed the registry, perhaps. Yeah. Honestly, sure, let's embed the registry. So we don't have this new entity. Let's remove this. Okay, so you give us a name and then we need to create a registry. Let's do your registry, and we can ask you for a size. Max entities. What's this? UN32 makes sense. Assert that size is bigger than 0. Registry size must be 1, must be more than 0. Okay. This should do it. So now our test code, and we need to write tests for this. We don't create entities like this. What we'll do is first we'll get a level. Stuck again. Let's do level, please. Level dot new level. Test level, and let's say max entity is 1000. Come on, go. You can do it. Oh my god. I have no idea why it's so slow. Someone needs to go on and fix this. I think it's the Go language server or something like this that usually gets stuck, which is just disastrous. Level. Right, let me help you here. There you go. Let me know this as well. Oh man. Ugh. Final. Now you put them back, it works. It's crazy. Okay, so we have a level. Then we can ask it dot registry dot, I don't get it. Registry dot. Did we not expose the, yeah, dot new entity? What's up? Expected identifier. Yes, you have it. Are we not returning level? We are. New entity. What's up? Invalid type. It's not field or method NewEntity. Why is the registry invalid? Oh, we have an error here. Where? It's circular, right? It's circular dependencies. Sure, I'm very sorry. We'll put test here. There you go. And this guy is like entity dot, and I can take the transform components, move it right here. There we go. Okay, now I reset. Could not import. Very nice. Okay, and then entity dot. Still sad now. Nope, it works. Okay, this is being stupid. So this is good. Now we can start to even make editors, save, load, all those kind of things. Although Visual Studio is completely dead, so restart. Right. So let's print. Let's print our entity, and our entity is this. Oh, we should see an ID of what? 0. Oh yeah, so the very first spot in the ID is a problem, right? Because it's the same as our invalid ID. So I don't want that. Registry should never return 0 as an ID. So that's a good test case. When we get an entity, we should never have it be ID 0. So in here, we can also assert that e.id is not equal 0. Entity ID must not be 0. Okay, so how? So because this ID is really an ID into the array itself, we can -1, for example, or +1 here. So instead of doing I, we do +1. And then when we come to index, we just -1 and then index and see. That's it. When you're searching, you give us an ID and we search for you. Just so we never hit the 0. Or we actually use the flags. I think this is fine. ID 1. I think this is okay. Yeah, so now we get ID 1. If we create 2 entities, let's create a bunch. So level.registry.NewEntity. Okay, so we have 1, 2, 3, 4. So they're, being placed in different places in the array. I think this is a good stopping point. Next time we can continue the registry. So we have new entity. We can do like has entity, get entity, things like this. And then when one entity wants to reference another one, all it has to do is simply store the ID. It's just a UN64. And then you send it to the registry or to the level, and you say, does this guy still exist? And if it does, you can take a pointer to it. And then you throw the pointer away, and so on. So every frame, we kind of throw pointers away to make sure we're not touching entities that have become expired, and gives us a good place to clean up. Yeah, I think I'll stop here. Oh, hey Daniel, what's up? How are you? So yeah, so I guess as a review, maybe we'll move registry down. That makes more sense. I'll actually make another file for registry. Go package entity. Let's put registry and save here. That's it. So we have entity ID. We're thinking something like this. Components. Now entities will probably have some functions. So we need an update, for example. Right now, what we're doing is we call your own update like this. But if we make an editor, and this is fine if we want to keep a library, like if you want a library just bare bones and you want to do everything yourself, this is okay. But if we want something more like the Unreal experience, like it's a full-blown game engine, does a bunch of things for you, then what we want to do potentially is we loop over entities, and for any active entity, either by checking the flag or having like a separate array for active, separate for inactive, there is a lot that can be optimized here, or like, different trade-offs. We can call an update function, and then the entity can decide whether to call, for example, maybe update on components if it wants. Maybe here we can require like, oh, you should have an update function on the interface. And so the entity can update its components in any order it likes. Yeah, maybe. So we can definitely, like, there is a lot that can be done here, and it's all very specific to what one would like. Yeah. Because my idea here is, once we have this, we kind of already have a level, very basic thing. We can start building an editor, and all the editor will be is kind of, what I'm thinking is, nMage remains a library, and the editor is simply a program that uses nMage. So it's like a game itself. It just runs on nMage and gives you a way of interacting with it. If you don't want that, you can still use nMage your own way, build your own editor, and use it, for example, with a different component system, with different trade-offs, different way of handling things. Completely okay. But yeah, like, you kind of need to be careful to still allow people to do that. Because if you have an update function like this, which is just one global function and your entities are yours, you can make your own loops over the entities, over the registry. You can make a bunch of different registries. But what an engine and editor gives you, instead of just a library, is that it does this for you. This code is kind of implemented for you. It literally just calls update on your entities, and then all you have to think about is like, okay, I have an entity, and the entity gets called. Gives you very smooth experience, while the library gives you the most flexibility. Yeah, or we can keep this, and we just have some basically helper functions. So the level can have maybe updates, just a function called update all active entities, things like that, which is fine. But yeah, I like this. I think it's very good progress today. Let's comment this out. We might use it next time. This guy is done. And what do we need? Complete entity registry, e.g., has entity, gets entity, etc. All right. Helper functions to update entities, active entities. Here, generational indices, things like that. Yeah, this we can do next time. And today we have this get component, get all of type, and registry, and so very simple. It's more of an organizational thing than a hard tech thing, which is a nice change after all the OpenGL stuff, which can get a bit hairy. All right, so I think this is it. Thank you everyone so much for coming. See you next week.